Potential energy of a particle of mass 1 kg is given as U is equal to 3x plus 4y. The position of the particle at rest, at time t is equal to 0 is given as 6, 4. We have to calculate various factors from it. Now understand that work done will be equal to negative of the potential energy, which will be negative of 3x plus 4y. Okay. Now over here, if I want to calculate the force in the x-axis, it will be partial differentiation of du by dx. Okay, now the partial differentiation means that when I differentiate it with respect to x, I say that the y is constant, and when I differentiate with respect to y, I say that the x is constant. So when I differentiate this part, the force in the x-axis comes out to be minus 3, and the force in the y-axis will be similar to minus du divided by delta y, okay, partial differentiation, which will come out to be minus 4. If I calculate the acceleration in the x-axis, it will be equal to fx, force in the x-axis, divided by mass is 1 kg, so minus 3 divided by 1 will be equal to minus 3, and acceleration in the y-axis will be equal to minus 4 divided by 1, which will be equal to minus 4. Okay, so now the total acceleration will be equal to root of ax square plus ay square, which is equal to minus 3 square plus minus 4 square, which will be equal to 5. In this case, it will be equal to minus 5 meter per second square. Okay, so the option number A is correct, that is the total acceleration comes out to be minus 5 meter per second square. Let us see the velocity when it crosses the y-axis. If I take a particle over here, it is originally situated at 6, 4. That is, the x coordinate is 6 and the y coordinate is 4. Now over here, if you see, the acceleration is minus 5, that is minus 3 in the x-axis and minus 4 in the y-axis. So the trajectory will be somewhat like this. Okay, the trajectory will be somewhat like this. Now since the acceleration remains constant in the x-axis as well as in the y-axis, okay, so it will track a straight trajectory, that is along it will track a straight trajectory or along a straight line. Okay, so now let us see this part. Okay, let us see when it crosses the y-axis, what is the x coordinate and what is the y coordinate. When the particle crosses the y-axis, I do not know the y coordinate because I do not know this difference, but I do know the x coordinate, that is I do know this distance, that is x. The displacement is minus 6. When it reaches this point, the x coordinate will be equal to 0. Okay, I do not know the y coordinate, but the x coordinate will be equal to 0. So now the total displacement over here will be from 6 to minus 6, 6 to 0. So it will be equal to, total displacement in the x-axis will be equal to minus 6. So Sx will be equal to ux into t plus half a t square. So over here, the displacement in the x-axis is equal to minus 6. Initial velocity in the x-axis as well as in the y-axis is equal to 0. Half acceleration in the x-axis is equal to minus 3 into t square. So if I calculate the value, t will come out to be 2. Okay, that is minus 3 2s are minus 6. Okay, 2 into 2 is equal to 4. So the time period will come out to be 2. Let us see the velocities in the x as well as in the y-axis when the time is equal to 2. For the velocity in the x-axis, Vx will be equal to ux plus at. Okay, now the velocity in the x-axis will be equal to, initial velocity is equal to 0. Okay, acceleration is equal to, acceleration in the x-axis is equal to minus 3. The time period is 2, which will come out to be minus 6 meter per second. Okay, the velocity in the x-axis is equal to minus 6 meter per second when it crosses the when it crosses the y-axis. When so the velocity in the y-axis will be equal to the same formula. Instead of ux, it will be equal to uy. So it will be uy plus at. So the initial, that is acceleration along the y into t. So initial velocity along the y-axis is equal to 0. The acceleration along the y-axis is equal to minus 4. Time period will remain same, that is the 2 seconds. It will be equal to minus 8 meter per second square. Okay, minus 8 meter per second, sorry, minus 8 meter per second. So the total velocity when it crosses the y-axis, it will be equal to root of vx square plus vy square, which is equal to vx square plus vy square, which is equal to 6 square plus 8 square, which is equal to 10 meter per second. So the velocity of the particle or the speed of the particle when it crosses the y-axis is equal to 10 meter per second. So the option B is also true. Okay, now let us see, it crosses the y-axis at what coordinate. Okay, so now basically I know that when it crosses the y-axis, the displacement along x will be equal to 0. Let us find out the displacement along y. I will use the formula Sy is equal to uy t plus half a t square. Okay, a y t square. I do not know the displacement along the y-axis. Let it be as it is. Okay, initial velocity along the y-axis, it is equal to 0. Half acceleration along the y-axis. If you see the acceleration along the y-axis, acceleration is given as -4. Okay, -4 into 2 square. Okay, -4 into 2 square, it will come out to be -8. The total displacement along the y-axis is given as final position. I do not know the final position, minus the initial position. Initial position is given as 4. Let the final position be as it is. Initial position is 4. So if you calculate the value, y will come out to be -4. Okay, y will come out to be -4. That is, the position of the particle when it crosses the y-axis will be equal to -4. Okay, so that is option number C is also correct. Okay, does it pass through the origin? No, it does not pass through the origin. It passes through the point 0, -4. So if I draw the actual line, it will pass somewhat like this. That is in the negative y-axis. Okay, so option number D is incorrect. So the correct options are A, B and C.